Alright, so welcome back. We are going to look at the derivative of an inverse function. So we're going to be taking the derivative and finding the general formula to find the derivative of an inverse function. So recall, for an inverse function, we have that the x and y values are swapped. That's how an inverse function works. So the first thing we're going to want to do then is we're going to want to let g of x equals f inverse of x be the inverse of f of x. So g of x is the inverse of f of x. This also means that g prime of x is equal to the derivative of f inverse of x. So given those two pieces of information, we can go ahead and determine the derivative. So if you have f of f inverse of x, this will always equal x. If you take the composite function of a function and its inverse, you always get x. So now we're just going to rewrite that as f of g of x is equal to x. And then what we're going to go ahead and do is take the derivative. So we take the derivative of both sides with respect to x, and we get f prime g of x times g prime of x is equal to 1. This is because of the chain rule. We need to take the derivative of the outside function and then the derivative of the inside function. So our goal here is to get f inverse of x all by itself. But not only f inverse, but the derivative of f inverse. And remember, we let f inverse equal g of x. So our real goal is to get this isolated right here. So to do that, we're going to divide both sides by f prime g of x. And we get g prime of x is equal to 1 over f prime g of x. Now we're just going to set, I only want an f function in my answer. So recall that g of x is equal to f inverse. So this is equal to f inverse prime of x. So we get that the derivative with respect to x of f inverse of x is equal to 1 over f prime of f inverse of x. What this means is, to find the derivative of the inverse, we don't actually need to find the inverse function and then take its derivative. All we have to do then is find the derivative of the function and a point in the inverse. Okay, let's do an example to show what I mean by that. So determine the derivative of the inverse function if f of x equals 1/3 x cubed when a is equal to 2. So I want it when x equals 2 or a equals 2. It's the same thing. So the first step is to write down the formula. The derivative of the inverse is equal to 1 over the derivative of the inverse at a point. So this really is what we need to figure out. So let's go ahead and do that. Normally, we have y equals f of x. That's what we normally have. But now, because it's an inverse, what we're going to go ahead and do is swap these. You get x equals f of y. And so our y value in this case is 2. So x equals f of 2. Now the way to get the 2 by itself is we're going to go ahead and take f inverse of both sides. So you get f inverse of x is equal to 2. Now what we need to do is we're going to go ahead and take that 2 and we're going to plug it in there. So we get the derivative of f inverse of x is equal to 1 over f prime of 2. So from here, we just need to know what f prime of 2 is. We got to figure this part out. Well, we know that f of x is equal to 1/3 x squared. So f prime of x is equal to simply, I'm sorry, this should be a 3, is just going to be x squared. So f prime of 2 then would be 2 squared, which is 4. So we get that the derivative of f inverse at 2 is equal to 1 over 4. And that's it.